Hey YouTube, how's it going? Welcome back to part 16 of our multiplayer game with Unity and Node.js. Today we're going to be handling AI movements. We're going to be going over turning our tank towards the player, not just like the barrel where it just snaps. We're going to be rotating towards. We're going to be moving towards the player using a forward vector on our tank. So we're going to be using our rotation and calculating a forward vector from that. And we're also going to implement some basic logic to have our tank not just basically come over and sit on top of our guy. So they will stop within a certain distance. They'll start backing up. That sort of stuff is very basic, but at least gives us our movement. As a little example, you'll be able to see he rotates towards us. And when we're at a certain distance, he'll start moving towards us, and it's all smooth and beautiful. And you'll see we move the spawn point of our guy up to the top where he belongs, and it's just so we can see results right away, which is kind of cool. So this is what you guys will be learning in the tutorial. Stay tuned. Alright, so we're going to start things off on the server here. So if you want to go ahead and get that booted up, lit up, that'd be great. And today, so the first thing we're going to do is, right now our AI kind of like spawns on top of our guy. So we're actually going to roll down to our, I'm just going to control F this, our on spawn AI into the game. And I'm going to just set a default. Now, most of you probably read the comments, you've probably done this yourself already. If you're still following along, still have them at 0, 0. I'm just going to change it to -6, and then 2. So I'll kind of put it up in like our top left here. And the idea here is that by pushing it away from our player, it will start rotating, it'll start moving towards our player, that sort of stuff, and we can see feedback like right off the get-go. Okay, so we're gonna do that. I'm gonna save. And I'm just gonna get my server started here. Beautiful. And cool. Okay, so we're gonna go into our AI, to our tank AI first. And the first thing we're going to do is we're going to add a new stat here. And we're going to call this tank stats. And we're going to add a rotation. So this rotation, you can call it body rotation. You can just call it rotation if you want. This is going to be the rotation of the tank itself, not necessarily the barrel. So what we're going to do is we're going to have the barrel rotation be calculated kind of like we do down here and applied. But the tank is something we need to store so we can calculate like a forward direction and all that information. Cool. Okay, so in order to do movement, we're going to do a couple things. We're going to do the tank rotation first, and then we're going to do the forward direction after that. So after this rotation nan here, we will do movement. Okay, so the first thing we're going to do is we're going to calculate a difference between the two angles. So that's going to be the angle that we're trying to achieve and the angle that we're starting at. So in this case, we're starting at 0, and wherever the angle between us and the player is going to be the goal angle, right? So we've already calculated that based on the barrel, and we're going to let the barrel, like I said before, we're going to let it snap. But we'd like to find that rotation. We'd also like to find out whether we have to actually move left or right in order to get to that rotation the fastest. So we're going to be doing a little math to do that, and we're actually going to be doing that in the AI base here. So if you want to go to AI base, I'm just going to drag it over here. We'll go to the bottom. We're actually going to add a couple functions before we get there, but the first one we're going to do is our get angle difference. So this is that little thing that I just said. We are going to calculate the difference between angle 1 and angle 2. And we'll just leave that blank for now. We're also going to need a conversion between degrees to radians. Just like before, we're going to give you it's going to be a static number. So we're going to say return new number. This is going to be 0, 0, 17, 4, 5, 3, 2, 9. And for anybody asking where this comes from, this is your pi, which is 3.14 times 2 divided by 360. And radians degrees is 360 divided by pi times 2. So if you're wondering where these numbers come from, this is where they come from. The next thing we're going to do is, in order to determine the forward vector, which is later on, we're going to need a world up vector. This might be different for your game. Within Unity and the 2D spectrum, I found that my world up was actually a vector of -1 in the y. Just kind of do the math, and if you're in like a different Unity axis and you're finding going a different way, just kind of flip the y there. And we'll get back to our get difference. So like I said, we're going to calculate the difference between our starting rotation and the one we want to go to, our goal here. And so the first thing we're going to do is we're going to calculate the difference between the two. And this is like some math that I've just had like lying around for like a really long time. But the goal basically is to kind of keep it in the same spectrum. And then that way our end result is like, oh, if we want to go left, you got to go -15 degrees. Or we got to go 15 degrees positive. So if you're ever curious, there's tons of examples online to where this math's actually being done. Yeah, so we're going to return the difference if it's less than -198. We're going to return difference plus 360, so we're going to wrap it around. Or we're just going to return the difference. So like I said before, it's either going to get us left or right, basically like a negative or positive degree. Which is super handy. Go back to our tank AI, and in our angle amount here, we are going to do AI.get angle difference. We're going to do AI.rotation. So that's the new value we put up at the top in the constructor, followed by rotation, which is the one that we calculated for the barrel rotation here. So this is the direction we need to, we need the angle to rotate. There you go. Now, so with the barrel, we just kind of just like snapped it, right? And then with this, we're actually going to perform what we call an angle step. So the update function happens every 100 milliseconds. So just like in Unity, you'd use times delta times time.delta time. This is kind of similar. We're going to calculate a step, a rotation amount per step. So we're going to do that is by angle amount. We're going to times this by AI.rotation speed. So we actually don't have that yet. And I'm going to put this inside the base class. So inside here at the top, I'm going to add this dot speed. And this is just like an arbitrary number here, by the way. It's just what felt nice. And then rotation speed. And just for now, I'm going to have them equal to each other, but you guys can play around with that. This is going to be like forward movement speed, and this will be like our tank rotating side to side. Okay, so we're going to get our step by the amount that we get back. We're going to times it by the rotational speed. And then we're going to take our, so that's, don't just snap, but move towards. Cool. I guess rotate towards might be a better choice. Cool. We'll do AI.rotation now. So we're going to fix our rotation. going to be equal to AI.rotation plus angle step. Right, so we're going to increase it each time we do update. Apply the angle step. And then, just for now, this might be a little handy. We're going to do a console log. And we're going to do AI.ID. We're going to do the barrel. We're going to store the barrel rotation, which is going to be a rotation. And then tank rotation, which is AI.rotation. Beautiful. Might help when you're debugging just to have that sort of stuff. The other thing that we have to do really quickly is update this guy with AI.rotation. Beautiful. Okay, so if we go in, server's running. We're gonna go in here and play. We'll join now. You'll see our tank is kind of facing, if you remember, it's basically 90 exact degrees away from us, right? And that's because we have that offset from all the art. So we do have to apply all that when we go do it. And we will do that client side for this. But for now, you can see that it is indeed rotating to stay with us. Which is pretty cool. Okay. So, the next thing we're going to do here is we are going to, back to the server, we're going to do the forward as well, and then we're going to combine these into one call. And then that's where we'll do all our kind of correction stuff. So, in order to do the forward vector, we're going to do let forward direction equals AI dot get forward direction, and we don't have that yet. So I'm going to put this in tank AI. We are going to have a get forward direction, and we're going to say let AI is equal to this. So the first thing we're going to do is we're going to calculate the radians rotation from our current value. We're going to get a sine, a cos value from it. Then using the vector up, we're going to be able to determine our forward vector from our player using some trigonometry. So we're going to do let radians rotation. It's going to be equal to, so in this one, when we're doing the rotation forward, because we're modifying the position on the server itself, we do actually need that arbitrary 90 to offset the artwork. Just in this case, in the tank rotation, we can do it on a client, but in here we have to actually be like, oh, you know what, like 90. Otherwise, our tank actually won't move, even if we did the art offset. The vector that we're telling it to go forwards is incorrect, so it actually never reaches the direction it should have been going. We're going to say AI.degrees to radians, which is something we just made. And I'm just going to make a note here. We need the 90-degree art offset to get the correct vector. Cool. Alright, so let's grab the sine value from that. I'm going to say math.sine. We're going to say radians rotation. Say let.cos is equal to math.cos of radian rotations. Cool. Let's grab the world up vector. And that's that little function we had here called world up vector. And then we're going to make some tx here, which is going to be equal to the world up vector dot x, and this is simply just to make our formula down at the bottom a little bit easier to read. Beautiful. Okay, so in order to calculate our stuff here, I had to turn off the beeping there for a second, apologies. We are going to, and I'm just going to do the brackets really quick here, but we're going to use some nice fun math. So we're going to do cos times tx, and then sine times ty, and sine times tx, plus cos times ty. So the y's and the x will always stay for second. You flip the cos to get it into the correct position. Here, just some nice vector math. Okay, cool. So that will get our vector forward direction. Using that, we can apply it to our position here. So we'll do that right here. From forward direction, we'll say AI dot position dot x is equal to AI dot position dot x plus the forward direction dot x times AI dot speed, which we added in the base class. Now we can be lazy. We'll copy. We'll change everything to y. Beautiful. And the last thing we're going to do is do the combinational update so we can kind of see everything. So we're actually going to take this away, and we're just going to have a function called update AI here. So in order for this to work, we have to go change the base class, right? Save that, as well as the game lobby, where we update all the stuff, and that's in lobby base. So if you open up lobby base here, you're gonna see we have two. We're gonna get rid of the second one. So if you want to grab the curly brace here, you'll see it shows where it starts. We'll get rid of that section. That was the update rotation. Now we're left with the update position, and we're actually gonna call this update AI. Beautiful. Okay, so what do we need to send the AI? Well, we're gonna send it its ID, tank rotation, barrel, and positional data. So if we come over to here, we're gonna say position is gonna be equal to AI dot position, and then because it's a vector, we have access to JSON data, which is a handy utility function if you open up vector2. Okay, so basically we're just kind of condensing everything into one packet, and that means now on our client we also need to add this event here for us. So we'll go into our network client manager. We'll come down to here. We'll say on update AI, and bring in an E. Beautiful. And you're gonna see a lot of copy and pasting, and that's just because we're kind of just doing both, which is super handy. So we're gonna take the ID positional data as well as tank data. In this case, actually, we're just, so you can just cut this guy because this is just for AI. And we can return this back to its old way here. Beautiful. We can do this for now. We'll need the network identity as well. So that's our barrel and tank rotation. And for positional data, we do the position update. Beautiful. Okay, so now we're gonna change this. This is gonna be incorrect. We need a set, like an AI manager call here. So if you want to open up the AI manager, we will have a function, public void, set tank rotation, float value. We already from the last one had the transform brought in. So we can just grab this guy here, replace it with the barrel transform, go back to the network client. Much easier just kind of like copy and replace these lines for sure. Set tank rotation and tank rotation. Beautiful. We'll leave the position the same. Okay, cool. So if we go back to the server's ready to rock. Let's start this bad boy up. And you'll see he's rotating, he's going in the direction, and he just kind of keeps going until he hits me, and then does like some rotational thing. That's fun. But I mean, like, overall, in theory, and he's a little laggy. We're gonna try and fix that based on, if you saw my my sample at the start of this video, it looked a little bit better than this. And you're gonna see, just like with the raw data, that he goes forward and he's like turning, he's looking at me, and all the things you would want from movement. And yeah, let's fix some stuff. So the first thing we're gonna do is let's not have him run into me, because that's not a lot of fun. So if we come back to tank AI here, the first thing we're going to do here is if the position, and we're going to calculate this based off distance. So we don't have this yet, but you can just write if distance is greater than, we're going to just use an arbitrary 3.5. Really doesn't matter, this is up to you. This is just a distance unit, and whatever you want to make that distance is completely up to you. Okay, and let's calculate the distance. We might need it later on, so let's just put it above our barrel rotation. We'll say calculate distance, because you'll use it in a lot of your calculations in terms of like what you want your AI to do. Maybe it's grabbing a flag, maybe it's doing that sort of stuff. And we're going to use our vector2 distance on the target position, not connection there. And so if the distance here is greater than 3.5, then we can go. And we'll just kind of show you what that looks like here. So he's going to run at us, and then he's going to stop. So 3.5, just arbitrary units here. The other thing we're going to do is if distance is less than or equal to 2.5, let's do this calculation, but we're actually going to go in the negative forward direction. So our back direction, we don't have to recalculate it, just because we know forward it's going to be the opposite. We can just minus it from it. And basically that's gonna make our tank kind of do like a runaway effect, which is kind of cool. So I'm just gonna rotate my tank just so we can get ready. And you'll see there's a little gap between 3.5 and 2.5, right? Where he's just sitting there. And then if I get too close, he's like, oh shoot, gotta back up, yo. And then if I back up, he starts running at me. And if I get too close, he's like, oh, yo, go back. Beautiful. Okay. And then the last thing that I did was I found I didn't like the tank moving all the time when it had large amounts of a rotational to like get to. Like basically if you're 180 behind him, and then he would just like, it would take him forever to like loop back around. So I'm gonna just do a check to only move forward if our math.absolute value, so math.absolute returns, if you had a -3 and a +3, it always returns 3. It only returns the positive version of it. Basically, it just gets rid of the sign. Super handy for calculations. Basically, the angle amount is less than 10. So, like I said, this is arbitrary. If you find you want to change it, that is totally up to you. Then we'll do the less than or equal than calculations. Just makes it a little bit nicer. But it's totally up to you. This is more just for the demo here. And let's go ahead. We'll play that. And he's going to run at us. And you'll see if I get too far away, see how he's not running, he's just kind of rotating with us. It's just kind of cooler. But then as he gets closer, then I guess you'll be able to see if I do this. He'll be like, oh shoot, no man, I gotta start running at you. And this is just like very simplistic UI, or AI, sorry. The last thing we're gonna do is kind of try and smooth out his networking calls. So the networking calls for AI happens every 100 milliseconds. That's a lot of frames if you're running at 60 frames per second. So our goal here is to use some smoothing techniques. Now this isn't interpolation or anything like that we could add in the future. This is just client side kind of trying to smooth, similar to like the bullets and that sort of stuff. And there's a variety of ways you can do it. You can just, I could be giving vectors that the tank's going in and handling it that way. Just when I was kind of quickly like putting it together, I was like, oh yeah, this would be super handy if we use coroutines to smooth it. So that's actually what we're going to be doing. We're going to be doing a couple coroutines here just to try and smooth it out a little bit better. So if you want to go into AI Manager here, and the first one we're going to do is we're going to do the tank like body turning smoothing. So that's if you guys have never used coroutines before, essentially they don't actually run on a different thread like Unity's ones do, but it gives you kind of the premise of multi-threading in a sense, where the execution of this code doesn't actually stop the rest of your code from functioning, which is super handy. So if you're doing things like fades and stuff, you can kind of just have it like a coroutine, you set it off and it does its thing while the rest of your Unity scripts and stuff are still going. So you'll see there's an error, and like I said, if you've never used it before, the first thing you always have to do is yield return null. So rather than returning null, it's asking for like an interface, the I enumerator, and so it requires the yield keys. So the idea behind the yield key is like you kind of stop processing and then you go again. So there's a few things you could do. Just the return null just kind of does like a return. You could do a return new waits. You could do a bunch, like you have wait until, wait while, wait for seconds, wait for fixed updates, real seconds, that sort of stuff. We're gonna do end of frame. That way it just kind of like, it does its animation, end of frame does its animation, and it'll kind of help with our smoothing a little bit. You can also yield other coroutines, which is kind of cool. So if you had a big processing thing that you wanted to do, and it required a bunch of littler coroutines, you can also do that. Okay, so the first thing we're going to do is we're going to have count. And count is simply just, like I was saying, the server's running at 100 milliseconds, which is 0.1. So we're going to try and sync it to our best. Like, it's not going to be one-to-one with the server update. Right? Because, like, you have to, like, the server's going to update 100, but then it's going to have the packet delay from your ping, that sort of stuff. Then we're going to have our current time that we're running at. 0. Current time is plus equal to time.delta time. The current time is less than count. What we're actually going to do is we're actually going to lerp. So we have this, right? And what we're going to do is we're going to take this guy here. And then we're going to say new vector 3. So basically x and y are 0. So we don't need to lerp vector 3 here. What we can simply do is just math.lerp, and we can make this easier by doing float z here, math.lerp, and we'll do the start rotation that comes in along with the goal rotation. So those never change. Basically, we're calculating the time step, but in Unity, essentially. And in order to do that, we're going to say our current time divided by count. So if you had a 10-second animation and you're 5 seconds along the timeline, it's going to give you 0.5. It's going to give you a normalized value between 0 and 1, which is super handy. This is going to give you, if this was 5 seconds out of 10 and you were going from 0 to 1, it would give you 0.5 here. Or 0 to 2 would give you 1. So yeah, it's lerping between the values based on t as its line, and you could even hook up the Unity animation curves to all this stuff, which is super cool. So we're gonna math lerp to the z here, wait for end of frame, let it come back, do its thing, and we'll have to remember the barrel rotation here. So I'm gonna just remove this line here. And we're going to do a start coroutine, and we're going to say it's the animated tank turn. Sometimes you'll see online where they do it in quotes. They'll be like, quote animated tank turn. You can do that. I think that's more of an old school way. But you can actually put the actual function. It's a little different. When you do coroutines, you have to actually put the parentheses and stuff. It's kind of weird, but you get used to it. We're going to do the local Euler angles z value plus barrel pivot offset. Okay, cool. Right, so this is the same as up here. This is our start. We just need that start so it doesn't change, because if we kept grabbing it from here, it'd change, and we're good to go. The last one we're going to do is in the network client here. We are going to scroll down to just before we try to join the lobby here, and we're going to do another coroutine. We're going to say position smoothing. This is going to be a transform, AI transform, with the vector 3 goal position. We'll do our yield return, new, wait for end of frame. We'll say our count is equal to 0. Our current time is equal to 0. Vector 3 start position equal to the AI transform dot position. Current time. And you're gonna see this is like identical to the other one, just vector 3. We still need reference to the transform. That's why I brought it in instead. But we still have a start, a goal, that sort of stuff. Okay, cool. So the other one we used math.lerp, which is like for single values. Vector 3, vector 2, all those guys also have their own version of lerp, which is super handy, so you don't have to do X, Y, and Z individually. So we can just kind of lerp between start and goal position, and then, like I said before, current time divided by time, divided by count, I guess. And yeah. So we'll do that, and we need to call that. So we'll go back up to our AI update, which is right here. We'll say start coroutine, AI position smoothing. We'll say network identity.transform, new vector 3, X, Y, and then 0. Beautiful. Okay, so we will play that. We're going to join now, and you're going to see that, I mean, it's not, better if they were moving towards us. Okay. Time to live debug. So let's go down into here. We'll see what is up. Okay, so we got the count is 0. Oh, that's why. Sync with server. There we go. Alright. It wasn't animating because it was at 0 right away. Alright, cool. And it's going to start going. And if you go look, previous in the video was like much more choppier. So we're going to leave it at that for now. We'll be getting the topics for like interpolation, kind of deciding and that sort of stuff, then we'll come handle that. The next tutorial, we're going to start shooting, letting our player get damaged as well. Oh, beautiful. We killed him during a coroutine stop. Oh, fancy. We found ourselves a cool bug. Okay, well, let's fix that guy then. Alright guys, I'm back and I fixed the error we were just seeing. I also fixed the stuttering because after I looked in the error I was like, I made a mistake. And we're going to fix that right now. Okay, so the first thing that I'm going to go over, I literally don't know how I didn't see this before. So when I do this, and I do the first lerp, it's going to return once it reaches the end of the frame, but it actually never calls us back again. And so we only ever move one step, which is why it looked a little bit better, but not perfect. So yeah, let's fix that right now. So what we're going to do is we're going to say while current time is less than count. While it's less than count, we are going to increase time, and then in theory you don't need this. I'm just going to leave it there because I don't really want to change it. Then we're going to yield wait till end of frame. We were getting a null check, and what that is if we destroyed the character and this is still running to its 100th millisecond, this guy could be null. So we're just gonna, after the end of the frame has happened, we'll just be like AI transform. If it's null, we're gonna do a return here. So we're gonna say yield return null, and it should get rid of this for us as well. And we'll just kind of put the current time is equal to count, just in case. Okay, and then we'll do the return yield null here. Okay, beautiful. All right, so in the AI manager, let's go do the same thing for our rotation here. We'll say while current time less than count. Then we'll increase delta time, we'll do the check, we'll wait till end of the frame. This thing will get deleted along with the guy, so we don't have to kind of like worry about that one for its null check, which is why we only saw it once. We'll just return null just for safety reasons. Okay, let's try this out. We're gonna join, and you're gonna see immediately looks so much freaking better. And we're still running into errors. Beautiful. Cool. And it's running into there because the transform no longer exists for this. Okay, so in order to get around with this, we'll have to check if the transform is null as well. Bow, bow, Live coding with errors on the screen. Okay. Coroutine couldn't start because the game object is inactive. Oh, okay, that's fine. In order to stop that, we would have to have reference to this. So when you start the coroutine, you get a reference to it. And we'd have to stop it when we go to kill it. So for now, what we could do is we could leave that there. You guys could try that yourself if you wanted to. And we can also fix in the next video once I look at it a little bit more. But basically, when you start the coroutines, you get a reference. So you can be like, coroutine. This would be stored as a private variable up here. And then when I go to destroy the client on player died here, where I set it to false, I could check to see if it has AI manager. And if so, then I'll have to stop the coroutines. So let's do that. Okay. Let's get the AI manager. And then we'll say void stop coroutines. It's going to return to us an enumerator called tank rotation coroutine. Beautiful. Returns coroutine. If it is not equal null, stop coroutine. I'll stop that guy. And we'll do stop coroutine. Okay. Look at this live debug session. Oh, what did I put? Oh, stop coroutines. It's like you need to give me an enumerator. Ah, beautiful. I love the errors. Bum, bum, ba-da-da-dum, ba-da-dum. Bum, bum, ba-da-ba-da-da-da-da. Cannot be started because the object is inactive. Alright guys, took me a bit to figure it out. Love errors when you're filming. I swear I did not see this when I was doing my demo. I swear. Alright, so in your update AI here, just wrap our code where it starts both routines in the game object that's attached to the network identity, and then check the active in hierarchy, because what's happening is when the player dies, we are setting it off. And then also when player died, I'm grabbing the AI manager and stopping coroutines, which is the little coroutine we made to stop this guy here. And that should stop our errors. So fingers crossed. Third time's a try. Guy's gonna run at us. We're gonna shoot him. And no errors. So beautiful. So yeah, so we're gonna end the tutorial at that. That turned out way better than my demo, because my demo didn't even have the smoothing, and I was kind of getting a little annoyed, I'm not gonna lie, and then it was just a simplistic mistake on my phone. Yeah, so hopefully you guys enjoyed that. We're gonna be doing shootings now that the other tank can basically kick our butt. And yeah, as always, have a good one, guys, and we'll see you later.
Hey guys, I just wanted to make sure that I give a nice shout out to all my Patreons over on Patreon. They're going to be in the following list for you: Jaron Frost,
Arthur Zhang, ARVR 2020, Timothy McCoon.
Hey everyone, if you guys liked the video, make sure you guys click that subscribe button, give it a like, and make sure to comment. It really helps out. And if you guys are looking to support the project further, I also have my Patreon, which will be linked in the description down below. Thank you, and have a good day.